Good morning, guys. Sorry I couldn't be here with you today. I am in a meeting here at Parker all morning, so I am making you this lesson so that hopefully you will be able to continue on with your Chapter 4 work on trigonometry. We started looking at a bunch of this on Friday after, on Thursday after you guys took your Chapter 3 quizzes. And we made the unit circle, which was finding all of the angle and radian measures of the angles on the unit circle, and then also finding the sine, cosine, and tangent values of those. So you're going to want to have those out ready to help you with some of what we're doing today. You're also going to find it helpful to have a calculator out, because we are going to be doing some calculating of sine, cosine, and trig functions, and obviously have your notebooks open. So feel free to pause this whenever you need to jot some stuff down or try a problem on your own before I go through it. And then after this, you'll just have time to work on the 4.3 assignment. And then again, I'll be gone on Thursday also, so I'll have another recording for you guys. But then I'll be back on Friday to answer all of your guys' questions. Okay? So let's go ahead and get started. Today we're looking at right triangle trigonometry, which hopefully you guys remember. The acronym that we use for this is SOHCAHTOA. So sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So those are the three like super basic trig functions. And then last year I introduced to you guys the reciprocal functions. So this reciprocal of sine is cosecant. So that would be hypotenuse over opposite. The reciprocal of cosine is secant. So that would be hypotenuse over adjacent. And the reciprocal of tangent is cotangent. And that would be adjacent over opposite. So we'll see those again in just a second. Okay? So here is exactly what I was just laying out for you guys. Sine, cosine, and tangent, and then their reciprocal functions are the cosecant, secant, and cotangent. So remember, when you're looking at an angle theta, the side opposite from it is the side across, the side adjacent to it is the side next to, and then your hypotenuse is always the side across from the 90-degree angle. Okay? So here's our first example. It says, suppose that a right triangle has side lengths of 4 and 7 centimeters. Evaluate the 6 trigonometric functions for the smaller acute angle. So the first thing I'm going to do is make a little sketch of this. And I'm just going to make one of the acute angles theta. And since they are saying that theta is the smaller angle, that would mean the smaller side has to go across from it. And then the other leg would be 7. And before I go finding all the trig functions, I need to find the third side. So how am I going to do that? Well, I'm going to use Pythagorean's theorem, which says 4 squared plus 7 squared equals c squared. So I get 16 plus 49, which is 65. Let's take the square root. C is the square root of 65. So I'm actually just going to leave that as the square root of 65. And now I can go ahead and find my trig functions. So sine of theta is opposite, which is 4, over hypotenuse, square root of 65. Now, in most cases, you're going to see this as being rationalized, because remember, we can't have a square root in the denominator. I'm fine with you not doing that, because I was just talking to Mr. Boska, and he said that the AP test actually isn't taking points off anymore for not rationalizing the denominator. So if you want to leave it like this, that's totally fine. The only thing you have to be careful for is if you're correcting your assignments in the back of the book, our book will rationalize the denominator. So what they're going to do is they're going to multiply this by the square root of 65 over the square root of 65. which will give you 4 times the square root of 65 over 65. So your book's going to show you that. I'm okay with you leaving it like this, as long as you know that they are equivalent. Okay? So cosine of theta is going to be adjacent 7 over the square root of 65, and I'm going to leave that. And tangent of theta is going to be opposite 4 over adjacent 7. So there's our three basic, super basic trig functions. Now we need the three reciprocal functions. So the reciprocal of sine is cosecant of theta. And if sine is opposite over hypotenuse, then the reciprocal cosecant is hypotenuse, square root of 65, over opposite, 4. Reciprocal of cosine is secant of theta. And if cosine is adjacent over hypotenuse, then secant is hypotenuse, square root of 65, over adjacent, 7. And then cotangent of theta is going to be, if tangent is opposite over adjacent, then the reciprocal cotangent is adjacent over opposite, so 7 over 4. So there you have the 6 trig functions. Okay? So let's try another one. It says, suppose that a right triangle ABC has a side lengths of 6 and 3, and we want to evaluate all 6 trigonometric functions for angle B, where angle B is the larger of the acute. So I'm going to say angle B is here because that's across from the larger of the two sides. So again, first I need to get myself the hypotenuse. So 3 squared plus 6 squared is c squared. 9 plus 36 equals c squared. 45 equals c squared. Square root. Now I'm going to simplify this because 9 is a perfect square and it goes into 45. So c is 3 root 5. Okay? So now that I've got all my side lengths, I can go ahead and get all my trig functions. So sine of theta, or we can actually say sine of b, is opposite 6 over 3 root 5. Now, even though I'm not going to make you rationalize the denominator, you should still simplify it if you can. So this would actually be 2 over root 5. Cosine of theta is going to be adjacent, 3 over 3 root 5, which again you can simplify to 1 over root 5. Tangent of theta is going to be opposite 6 over adjacent 3, which is 2. Cosecant is our reciprocal, so 3 root 5 hypotenuse over opposite, which is 6. So root 5 over 2. Secant of theta, reciprocal will be a hypotenuse, 3 root 5 over adjacent, which is 3, so root 5. And cotangent is going to be adjacent, which is 3 over 6, which is 1/2. Okay? Got a little squish there. Sorry about that. Okay? Cool. Example 2 says, suppose that the cosine of theta is the square root of 5 over 3 for the acute angle theta. Evaluate the tangent of theta. So I'm going to draw my triangle, and I'm going to make one of my angles theta. And if the cosine is the square root of 5 over 3, that means the adjacent side is square root of 5 over the hypotenuse, which is 3. And in order to get tangent, I need opposite over adjacent. So I first need to get that third side. So again, I'm going to use Pythagorean's theorem. A squared plus square root of 5 squared equals 3 squared. So I get a squared plus 5 equals 9. a squared equals 4. Square root it, a is 2. So tangent of theta is going to be the opposite, 2 over the adjacent root 5. Okay? Now again, I'm fine with you leaving it that way, but just know that your book is going to rationalize this to the square root of 5 over the square root of 5, which will give us 2 root 5 over 5. Okay? Alright. Let's try another one. The sine of theta is 3 over 4. So that means opposite over hypotenuse. 3 over 4. I need to get my third side, so 3 squared plus b squared is 4 squared. 9 plus b squared is 16. Subtract 9, b squared is 7. So b is the square root of 7. Okay, cool. So what does that mean? The secant of theta is the reciprocal of cosine. So if cosine is adjacent over hypotenuse, then secant is the hypotenuse, 4, over the adjacent, square root of 7. Okay, so you can leave it like that, or you can rationalize it, 4 root 7 over 7. Either or. Okay? Alright. Example 3 and the skill practice for 3 and example 4 and the skill practice for example 4 are really just laying out the sine, cosine, and tangent and the cosecant, secant, and cotangent of 30, 60, and 45 degree angles, which we've pretty much already done on the unit circle. But I'm just going to quickly review with you how I got those, just in case you ever have to reproduce them. So it says evaluate sine, cosine, and tangent of 45 degrees. Well, hopefully you remember from the unit circle that 45, 45, 45, I'm sorry, 45, 45, 90 triangles have side lengths of root 2 over 2. And you really need to know that. Okay? So what does that mean? Well, the sine of theta is opposite square root of 2 over 2 over hypotenuse, which should just be over 1, so it'll stay the same. Cosine is the same, since the two legs are the same, adjacent's the same. And then tangent, when you take the square root of 2 over the square root of 2 over 2, anything over itself is just 1. Okay, so there you have it. Here, this asks for the cosecant, secant, and cotangent of 45. Okay, so again, I'm going to sketch this. Root 2 over 2, root 2 over 2, and 1 is the hypotenuse. So cosecant, and I don't want theta, I want 45. So, oh, come on now. Cosecant is the reciprocal of sine, so hypotenuse over opposite, root 2 over 2, which basically just flips it. So we get 2 over root 2, which if we rationalize gives me 2 root 2 over 2, which is just the square root of 2. Which is nice to know because obviously if cosine and sine are the same, then secant and cosecant are the same. And then again, cotangent will just be, instead of opposite over adjacent, adjacent over opposite, but they're the same. So it'll just be 1. Okay? And then example 4 is just your 60-degree angles, and example 5 is just your 30-degree angles. I'm sorry, your skill practice 4. So I'm just going to draw our 30, 60, 90. Hypotenuse is 1, cross from 30 is half, cross from 60 then is root 3 over 2. Okay, so we're looking at the 60 here. Sine of 60 will be opposite, so root 3 over 2. Cosine of 60 is adjacent over hypotenuse, so 1/2. Tangent of 60 is opposite, root 3 over 2, over adjacent, 1/2, which means you keep, change, flip. 2's drop out, we just get the square root of 3. Okay? For the 30-degree angles, again, I'm going to draw my picture. The more times I practice it, the more I'll memorize it. So the sine of 30 is going to be the opposite, 1/2. Cosine of 30 is our adjacent, root 3 over 2. And now this is where it gets interesting. Tangent of 30 equals opposite, 1/2, over adjacent, which you keep, change, flip. We get 1 over root 3. And even though I always tell you it's fine, in this case, because it's one of our very special angles, let's rationalize the denominator by multiplying it by the square root of 3 over the square root of 3, which gives me square root of 3 over 3. Okay? Perfect. So, at this point, I want you to pause the video and I want you to copy this beautiful table into your notes. Why? Because it's going to serve as a quick reference for you when you are doing the next problems. Okay? So go ahead and pause and copy this table. Okay, hopefully you've had a chance to copy that into your notes. We're going to use that now to solve some identity type problems. So let's take a look at example 5. Hold on here, my screen has frozen.